has to do with the factor theorem. The factor theorem says that if I have a factor of x minus 2, if I set that equal to, or x plus 2 that says, if I set that equal to 0 and solve that, x would equal negative 2, right? If my factor is x plus 2,
Yep.
then x is equal to negative 2. If I do p of negative 2, and they're going to make you type that into behind the parenthesis, if I get an answer of 0, then it is a factor. If I get any number other than 0, it's not a factor. So now we're going to grab our calculator, and we're going to put the negative 2 into our expression and see what we get for an answer. So 2 times negative 2 to the third plus 3 times negative 2 squared minus 3 times negative 2 minus 2.
I got negative 6.
You're faster than me. Minus 2. I didn't get negative 6.
Did you?
Did I not get it typed in right? Or did you not get it typed in right?
Maybe I didn't.
All right, type it in again.
Negative 2. Oh yeah, there you go. I didn't do the power.
Yep.
Oh, I got 0.
Okay, that's what I got. If this is 0, which it is in this case, it is a factor. If it equals 0, it is a factor. If it doesn't equal 0, it's not a factor. Since we got 0, it is a factor. All right, so number 11 wants to just to determine if x plus 2 is a, that's not supposed to say x plus 2, it's supposed to say x, what in the heck? Okay, I know she messed these ones up because she's got different stuff. Well, she's got x minus 3 here and x plus 2 there. Well, it says determine if x minus 3 is a factor, so that's what that's supposed to say. I think. Okay, I'm going to fix that. X minus 3. Okay, so we want to determine whether x minus 3 is a factor. So, if x minus 3 is a factor, then we have to use x equals what number?
3.
3. So we're going to put the 3 in the parenthesis, and then we're going to put 3's in and find out what our number is. So 2 times 3 cubed minus 6 times 3 squared minus 9 is what we're checking. I hid my calculator. Oh, it's over there.
I got negative 9.
I got negative 9 also. So if we get negative 9 for the answer, is x minus 3 a factor?
Yes. What kind of factor? No.
What did our thing say up there that I wrote beforehand? If x, or if it equals 0, it is a factor. If it doesn't equal 0, it's not a factor.
Oh yeah, okay.
It didn't equal 0, right?
Yeah.
So the only time it is a factor is if that answer comes out to be 0. If it doesn't come out to be 0, then it's not a factor. All right, number 12 was the same as number 10, so I've changed the problem here, and so just make sure you get the right problem. It says use the factor theorem to determine whether x plus 1 is a factor of negative x to the fourth minus x to the third plus 3x plus 8. Specifically evaluate p at the proper value and then determine whether x plus 1 is a factor. So, if x plus 1 is a factor, it would have to be equal to 0. Solving that, x would have to equal negative 1. So we're going to evaluate p of negative 1. So minus negative 1 to the fourth minus negative 1 to the third plus 3 times negative 1 plus 8. And you could figure that out on your paper or use your calculator, whichever way you want to do that. So, minus parentheses negative 1 caret 4 to the fourth minus parenthesis negative 1 parenthesis to the third plus 3 times negative 1 plus 8 equals. And so if I figured this out, negative 1 to the fourth would be 1 with the minus sign. Negative 1 to the third is negative 1, but minus a negative makes it a positive. 3 times negative 1 is negative 3 plus 8. And so those cancel. Negative 3 plus 8 gives me 5. So p of negative 1 is equal to 5. Now you have to decide, is it a factor or not? Well, if it's going to be a factor, it has to be equal to 0. We got an answer of 5, and so no, that is not going to be a factor since we did not get 0 for our answer. So that is the factor theorem to check if it is a factor or not.